Sure. And Brent, as I'm giving the presentation, if anyone has any question, feel free to ask. And I am minimizing my screen, so I won't be able to see if anyone raised hands. So feel free.
Yeah, I'm asking them to wait to the end. Okay. That way I'll mediate the questions.
Sure.
So with that, I am really thrilled to welcome you to the 11th session of the Unmanned Systems Guest Subject Matter Expert Speaker Series. I'm Dr. Brent Terwilliger, the Program Coordinator for the Master of Science in Unmanned Systems degree at Embry-Riddle. Tonight, we are joined by our guest subject matter expert, Darshan Divakaran. He's a senior manager at AFWERX. He's also an aerospace intrapreneur and technology evangelist with expertise in unmanned aviation, aviation development, geospatial analysis, emerging technologies, and program management. He has experience in a number of growing unmanned aviation areas, including unmanned traffic management, or UTM, Counter-UAS, or CUAS, and advanced air mobility, or AAM. He has led efforts to work with federal, state, public safety, industry, and academia to develop, integrate, and manage national and statewide programs and initiatives. He's also been recognized by Interdrone and Commercial UAV News as one of the top commercial drone visionaries. In addition, Darshan's a fellow Embry-Riddle Eagle, having earned his undergrad in professional aeronautics with a minor in aviation management from Embry-Riddle in 2010. And ironically enough, he is connecting to us all right now from Daytona Beach, where he and his colleagues visited the university today. So with that, I would like to turn the floor over to Darshan to talk to us about the use of unmanned system technology at AFWERX, including his personal insight and perspective concerning the evolution and growth of this technology.
Thank you, Brent. And I would say really happy to be back here in Daytona after 2 years. Really, I'd come down during the NTAS conference, in 2020, just before COVID, and didn't get a opportunity to see the facility. And I was telling today the folks at Embry-Riddle that as a student, you don't get to see this perspective that I got to see today. So I was pretty excited to visit all the facilities, talk to the faculty, and understand what's going on. And one of the key things for our visit today is to understand what Embry-Riddle can offer in the space of anything in the air technology side, from unmanned systems to space. So a lot of potential, and you will see a lot more AFWERX present here. So my background and how I got into AFWERX is something which is it's a useful knowledge in case you're interested in working with the government. And a lot of times people think that when you work for an organization like an Air Force or any DoD agencies, it's going to be difficult and it's going to be boring. Some people think it's going to be boring because it's the government, but I tell you, it's pretty exciting. You get to see innovative technologies. You get to talk to experts, and you get to see how the innovation wheel is moving forward. And one of those programs is the AFWERX program. And I joined AFWERX Jan of last year, after working extensively with universities, state and local, federal agencies. I realized that though we talk about innovation, the innovation wasn't moving in the pace that we wanted. And an example is small drones. By 2020, we were expected to see more drones in the airspace. We were supposed to see UTM, that's unmanned traffic management into effect. We were going to see drone delivery happening. A lot of things we were supposed to see by 2020, and you can blame it on COVID. But overall, the process has been slow, delay from the regulation side, delay with the technology perspective, also with battery and other technologies for beyond visual line of sight. So I decided that if we have to move the innovation wheel, you have to be a part of an innovation organization that is working towards it. So the opportunity with the Air Force was amazing. I got into working with eVTOLs, electric vertical takeoff and landing aircrafts. You can call it big drones, you can call it flying taxis, urban air mobility vehicle, advanced air mobility vehicle. But end of the day, these are technologies that are not traditional manned aircraft, and they are going to be flying in the airspace. So a lot of questions on how these aircrafts are going to fly, how it's going to be integrated into airspace, and what's the future is what AFWERX is working on. So I'll move to the next slide. Okay, so AFWERX, we are under the Air Force. So I work for the Air Force. I'm a government civilian. As I mentioned, I came from industry, academia experience, and got into the government because one is Air Force is interested in the air side of things, and that is my line of work. And when I got this opportunity with AFWERX, I did not know that AFWERX was more than just eVTOLs. So for those who aren't aware about AFWERX program, the three programs that you need to understand under AFWERX is one is the Prime, AFVentures, and Spark. And all these three programs are focused on transitioning agile, affordable, and accelerated capabilities by teaming commercial technologies and developers with Airmen and Guardian. What does that mean is we want to, so, it's good to read definitions and all these lines and stuff, but what does it exactly mean? The focus is that we are innovating from both external and within. We want to bring in innovative technologies for warfighting capabilities, operations capabilities, logistics support, but we also want to make sure innovation is absorbed from within. So how do we help educate our Airmen and Guardian by connecting them to academia, industry, by giving them that knowledge and education on how to use these innovative technologies. So why AFWERX? Those who understand the DoD space, or those who have heard these words like AFWERX, SoftWorks, they may think all of us are alike, but in a way we are, but we are slightly different. AFWERX. So what is AFWERX really? Why does AFWERX really exist? So if you look at the traditional DoD environment, the two focus is technology and talent. Technology are anything from aircrafts to you can from drones or anything, anything that's a technology, and talent is students, then experts, and everyone that is helping move the technology forward is talent. So how do we help bring technology and talent? And a lot of times those who have worked in government or know about or have people who work in government say that it's very difficult to work within the government because the process is long, and a lot of times they say the pay is bad. And technology also same thing. Technology programs go through pilot programs and then testing, various testing, and after years and years, sometimes these technologies take 10 years to transition into a capability technology. And sometimes they go through a valley of death wherein the program dies after spending millions of dollars towards that program. And the whole path towards technology and transition and talent transition is what we are trying to overcome, that valley of death. And that is where AFWERX comes into perspective. So AFWERX is solving technology and talent transition through Ventures, Spark, and Prime. And eventually, we are creating a expanded portfolio of capabilities focusing on autonomy, AI, quantum, hypersonic, your blockchain, anything that's out there on the innovation space. We are trying to bring that in and help grow the GDP for American economy and everything. So we want to make sure that American companies are successful. They are able to build a strong supply chain base in US. They are, instead of importing technology and parts, they are exporting it. So everything from the technology perspective to actually manufacturing, we are interested in every piece of it. So that is where AFWERX comes into perspective. Now, I won't dive into much about each of the programs except Prime. That is what is focused for you all. But I'll give you all a quick, information about each of these. So, AFVentures, for those who are aware about SBIR and STTR funding opportunities with DoD and federal agencies, these are small business funding opportunities. So an SBR is where small companies get funded from by DoD, and STTR is where small business and startups partner with research institutions and universities and submit for proposals. And there's like phase 1, phase 2, phase 3. Phase 1s are like $50,000. Phase 2s are up to 750K, and phase 3 are where the companies bring in matching and organization bring in matching funding, and it's up to 15 million. This is basically where we fund ideas to build prototypes, to actually build technologies, and eventually DoD and here, if you look at Air Force, can become customers for those technologies. But we are also interested in dual use technology. So we are not just interested in acquiring this technology for military applications, but also for commercial applications. We want the commercial market to be successful as well. So this is the, as the sentence says, we are the commercial, the AFWERX is the commercial investment group. So we take ideas, build technology, prototypes, and then scale it to technology. Spark, as I mentioned earlier, we are trying to innovate from both external and within. And from within is where the Spark program comes. So those, I'm not sure if you're aware about Spark cells, but many military bases have innovative programs where it's called, innovative programs or Spark cells. So in Air Force bases, there are Spark cells, which are we don't manage those Spark cells, but we help the Spark cells be successful. So there are Spark cells all around the nation, as well as internationally also. We have bases, we have Spark cells, and these Spark cells are where airmen and guardians are getting empowered, and we are building them their knowledge capability, but as well as taking their ideas. So these are folks who are actually, in the front line. They are actually doing in these bases. They are actually using these technologies, but a lot of times they have ideas to speed up process, to save time, to save life, and also save money. And these ideas is where can be connected to industry and academia, and we can help build prototypes and eventually technology. So we are helping innovate from within. We also create events through challenge, it's like a Shark Tank sort of thing. So we have Spark Tanks, and we have challenges and collider events. We give internship fellowship to airmen and guardian to get to work within the Air Force, but also with other DoD and also with academia and stuff. So this is where we are innovating from within. Prime, this is where this will be more of interest for you all, and the Prime program is where technology that is ready today, we are helping accelerate the commercialization and transition of these technologies for both dual use, that is military as well as commercial. So one of our primes is the Agility Prime program, and which I'll be talking about in the next slide. But AFWERX as such is focusing on prime programs where technology that's ready today, we can commercialize it. So I talked about ventures, AFWERX. AFWERX is where we take ideas and make prototypes. This is where we have actual prototypes that are built and ready to be operationalized in the next 2 to 4 years. So that is where the prime comes into effort, and basically we are looking to expand that partnership with industry, investors, other agencies, international allies, with our acquisition community, warfighting community. So we, and I love this line, prime the pump to advance US national security and economic prosperity. So we want to ensure these technologies are helping solve national security issues, but also we want to ensure these technologies and the companies are successful within United States, and they are able to grow not just in US, but in other countries as well. So as one of the key prime programs, so we have Agility Prime, and the other one is Orbital Prime. So just like AFWERX has 3 programs, we also have SpaceWorks, which is under AFWERX, and the new prime that was announced last year was Orbital Prime. That is I don't have a slide about it, but those who are interested in space studies and stuff would be interested to know that the orbital prime is trying to focus on solving one of the key problems in space, that is uh, debris cleanup, like all the how do we clean up all the debris around the Earth, and how do we bring in technologies and companies to solve that problem. So that's the focus on the space side. But Agility Prime is where we are focusing on electric vertical takeoff and landing aircrafts. And this is where we are looking towards rapid acquisition and commercial acceleration of eVTOL technology. And this is through a private partnership with industry that is actually building these technologies and flying these technologies. We are also helping them with early use cases, our DoD expertise, and also on the regulatory side. So we're helping with aircraft certification and military aircraft certification and stuff. But mainly we are helping these companies be successful through this Agility Prime program. So under the Agility Prime program, what is our main focus? So there are three focus. One of that is electric propulsion. We are trying to understand more about electric propulsion. There's a whole, you can also include hybrid, both electric and gas into it. But overall, we're trying to understand how the future of electric propulsion can help solve problems like reducing the cost of maintenance, the environmental, it's a cleaner system to use for environmental purposes, low noise levels. So a lot of things that traditionally would cost a lot and have environmental impacts, we're trying to solve it through electric propulsion. And we're still in the early stages wherein there are different companies focusing on different solutions, and we are trying to better understand that. So why are we focusing on Agility Prime? So if you look at this, chart, you can understand that most of our ground-based vehicles are overutilized. We use it for both logistic purposes like transporting people, cargo, and also in the warfighting capabilities. What is underutilized is our air assets. So our aircrafts are all, because of the limited range, where we are using for short distances, some of these aircrafts don't really fit the bill. Like if you're moving within a mile range, you wouldn't take a helicopter and go a mile, 2 miles away, and that costs a lot. Also, a lot of maintenance, and overall, expensive, very, very expensive to use some of these aircraft. So this is where eVTOLs or vertical takeoff aircrafts come for short distance use case. So we have identified short distance use for these aircrafts. So it's not going to solve your travel from, we're not going to be using this to travel from one state to another, one country to another. This is for short distance use. So why are we focusing, and why are the interest in this? So this answers that question. So we're trying to reduce the risk for industry to accelerate investment. So what is the one key thing that startups need to be successful? One is funding. Everyone wants money. Absolutely. Startup companies need the money to move things forward. But also look at one key thing is the tech risk. They do not have a safe environment where they can test and fail and succeed at the same time. Unless you test, you're not going to be able to know the capability of these technologies. A lot of times you have to fail during these testings to succeed. So where do you create a safe environment where startup technologies can be tested and failed and not cause any damage and everything? That is where we offer our through this Agility Prime program, we offer our ranges, that is our military bases, military location, military airspace, and testing locations to these companies to test their aircrafts. So that's a safe environment. We are working on regulatory risks. So that is where the airworthiness. Typically any aircraft, manned aircrafts, you have aircraft certification for the airworthiness and everything. Similarly, eVTOLs and drones, small drones, all of these require to have some form of standardized certification and airworthiness. So this is where we are, FAA still does not have a certification, a complete certification plan for these eVTOLs. They are working with the industry. I think it's called G1 or G2 certification, which they're going to be focusing on eVTOLs. But when you look at the big picture, it is still going to take some time to get a certification plan on the commercial space. But military is able to provide a military certification, and so these companies that are working, these eVTOL companies are able to understand better when the time comes for them to do a commercial certification. So we can solve about 60 to 70% of their problems, so that when it comes to commercial certification, it can be quicker. And when I say the military, values the FAA certification. So a lot of these aircrafts come under experimental, or they come as a helicopter certification and stuff like that. So they come initially as some manned aircraft, because we still have an operator on board. Even though these aircrafts are capable of being flown autonomous or remote, they still have a they still have an operator on board. So when you have an operator on board, it becomes more like a traditional manned aircraft. But because these aircrafts are different, they're electric and they're for short distance, they fall under a different certification. And that is where the AFWERX Agility Prime program is helping with the early stage certification and helping these companies understand what is required to be commercially certified with the FAA. And third part is the reduce to financial risk. As I mentioned, it costs a lot of money to build these technologies, and to also provide the customer, that is military, with if military has an order for like 20, 30 aircrafts, eventually 100 aircrafts, 200 aircrafts, how are they going to build these technologies? Where are they going to build it? They require that financial support. And who's going to be the earliest adopter of these technologies? So this is where AFWERX is interested in finding that end user within DoD to understand the capability of these aircrafts and potentially be the early adopter for these technologies. So if we start buying these technologies, they will manufacture more aircrafts, which will eventually reduce the cost for the commercial, on the commercial side. So that's the three focus. And through the Agility Prime program, we are able to work with them for a certification through our in-kind testing. And I'll be talking more about the in-kind testing. But if you look at the chart, we have compared the value for Air Force and value for industry. So early insight into military utility, and this gives access to government resources and expertise for industry. So traditionally, industry wouldn't get this experience of working with government subject matter experts and government facilities. It's very difficult for startups. And this really creates a good pipeline for them to work. And other stuff which I mentioned was the certification and overall low risk for the industry, because we take the risk of making sure that they are successful. So, more details about the Agility Prime program. How does these aircraft really fit into the Agility Prime air race? So we created 3 areas of interest. Area of interest 1, which is focused on 3 to 8 passenger. Area of interest 2, which is focused on 1 to 2 passenger. And area of interest 3, which focuses on the lift capability, so more for cargo use cases. So the maximum payload should be over 500 pounds. It should be able to lift over 500 pounds. So if these aircrafts are ready today and they fall in one of those areas of interest, they can submit their proposal, and there have been a bunch of companies that have gone through it. And there are other requirements on the range, speed, endurance, and when they did the first flight. But this is the way for them to work under the Agility Prime program. So how does that work is, say I'm a company XYZ, and I have an aircraft that falls under area of interest 1, and now I submit my initial evaluation, phase 1 of it, where I submit a proposal, which is basically saying that I meet the area of interest, and here are my details of my aircraft, and I meet all the requirements. So we will our program managers and subject matter experts will evaluate it, and if they see that yes, this company does meet those requirements, then we will do a phase 2, which is basically an engagement where either our subject matter experts and technical team will visit the facility where they are actually flying these aircraft, sit and examine the aircraft, see if everything that they mentioned earlier in phase 1 is true. Sometimes these companies give us demonstration during this phase 2 time, and a demonstration could be just as much as take off and hover around, or just even start engines to show the capability and everything. And when we see that they have the potential and they are following all the guidelines and everything, then we look at giving them a contract, which is an in-kind OTA, which is basically that there is no exchange of dollars between the Air Force and the company, but we are providing them in-kind support. So I'll give you more details on how what that in-kind is. But this is very beneficial because it reduces the cost for companies to do those testing. So I mentioned in-kind testing. So for those who are interested in aircrafts, you can understand that aircrafts have a lot of moving parts. They have a lot of important testing done. There has a yearly maintenance. There's a bunch of things that have to be inspected. So when it comes to these aircrafts, we are evaluating this technology through our in-kind testing, where we do aerodynamics, wind tunnel testing, CFD study, cybersecurity study for these aircrafts, airworthiness, acoustics, structural validation, vibrational testing, modeling and simulation, environmental, testing. So all these testing, which would cost the company thousands and sometimes millions of dollars, we are reducing that cost by paying directly to our partners. So we work with Navy, Army, we work with other federal agencies, NASA, FAA. So when these companies get this in-kind testing contract, they don't have to pay from their pockets. Basically, we take over that cost. So if we are using Navy to do, say, for example, human factor study, we will pay Navy directly for it. So we bring our subject matter experts to work with them, do this testing, and give recommendations. So if the company would like, we give recommendation, we don't tell them to modify anything unless it is going to cause a safety issue. So many of these companies take that advice and do modification and improve their aircraft. So we have subject matter experts on rotorcraft, cybersecurity, the structural side, and airworthiness side. So we also have contractors that work for us to solve these problems. So altogether, we save that money that the company is going to put towards this when they go for that FAA certification. So when they finish all these things, they get certification and good merit. And then this is where when FAA has a certification, maybe which would take them usually a couple of years to get, would take them a couple of months, and we would save that time. So I mentioned about the air race, that is the Agility Prime, and then I mentioned about the SPR and STTR. So here's just a comparison that both ways are finally leading to the same end result, that is potentially military being a end user, a customer, and also having commercial application. But there are different approaches. So through the air race and the Agility Prime, we are commercializing technology that are ready today. Through the SPR and STTR, we're taking ideas and making prototypes and eventually building, manufacturing more and buying them. So this is just a comparison. If I go back to the history and the success, so Agility Prime program started in 2020, and if you look at it in about 2 years, how much has Agility Prime grown, or what is the success? And this is what that highlights. So as I mentioned, the three focus for us is, when you look at Agility Prime, what is our three focus areas? One is electric propulsion. Two is autonomy. We are trying to understand the autonomy piece to this. So eventually all these aircrafts are going to be autonomous or semi-autonomous or remotely flown. but if, now they have an operator on board, not a pilot, an operator. The operator's job is to ensure that everything is green, buttons are pressed, everything is safe, and only if there is an emergency, then the person will take over. But right now there's an operator on board. So we are also studying the future, that is the autonomy piece. And then the third is the supply chain and manufacturing. We want to ensure that these technologies are built in US and able to boost the US economy. So we are, building a domestic industrial base, which is estimated to be 2.2 trillion market by 2025. So that is one of our goals. We are creating new certification contracts, budget to help these companies. And then think about it like this: by 2023, the military, the Air Force is looking to operationalize eVTOLs for specific use cases. We have already identified 20 use cases, but by 2025, you will see commercial use cases also identified and operationalized. It could be for medical delivery, it could be for humanitarian emergency response, it could be for short distance travel. A lot of use cases, a lot of potential. So this is slightly older slide, but in about 2 years, we have over 29 companies that have applied for the air race. Let me tell you, 29 companies have applied for it. Not all of them have completed the process. 4 have got military airworthiness, 2 are currently in process. So the remaining companies, when they are ready, they will go through the process, and then we have given about 100 million in contracts, which is 9 phase 2 civils. That is where is 750K plus. Around 750K awarded through those civils, and then 220 STTRs. And STTRs are where, just reminding everyone, that is where industry partners with university or research institutions. Co-investment over 1 billion in commercial investment, and then some of the successes that we have been able to create with the AETC Agility Prime detachment. We have been able to create simulators for training purposes. We have been able to create, we have set up charging stations at Springfield. So if you are at Springfield Airport, you can see some of these aircraft simulators, a charging station. We were able to transport one of these aircraft. So if you look at the right bottom picture, that's a lift aircraft being transported by a C-130J. And so you can see how easy it was. I won't say it's easy, but it's an aircraft that is flown with inside another aircraft to be transported. And then we have been able to show demonstrations to a lot of leadership within the Air Force. So with that, I would open up opportunities, to take questions and also discuss about small UAS and our interest with small UAS and eVTOLs. So I'll stop sharing and I'll open up.
Excellent. Can you all hear me? Can you hear me all right?
Yeah, I can hear you. Yeah.
Okay, perfect. Yeah. So I've got a couple questions I'd like to lead in with. Then I have 2 questions from one of my students that can't be here tonight. And then we'll turn it over to everybody that's here. So regarding tools or resources that you personally use to stay informed, what are they? What are some of the challenges that you find of sifting through the volume of data to stay up to date on the latest and greatest that are going on, and really those component areas that you have that strong background in: UTM, CUAS, and urban or advanced air mobility?
So, I love to read stuff and get information, but I like to have discussions with the subject matter experts and people who are leading these programs and stuff. So one thing I've been, I would say, blessed is that every job that I've been part of, from university to state to nonprofits, anything that I've worked with now to military, I've been able to be at the forefront with the technologists, with the subject matter experts to understand the challenges better. Because, when you read, you get a perspective from one person or two people, but that really is not an industry challenge. And that is not really a technology challenge. That is just a limitation of knowledge. So a lot of times I hear people talking about, because we are in the DoD, or I work for the state and stuff like that. I get people who come and say, I want to solve the UTM problem. Give me the money. And I'm like, yeah, if everyone who says I want to solve a problem, we give money, there's going to be more problems instead of solving those problems. So it's about having the right information. And a lot of people who are getting into the unmanned systems industry need to understand one key thing is that these challenges are not new. They've always existed. DoD has been using, drones for years. Commercial has been using it in the last couple of years, and they feel like it's a big challenge. No, it's only a challenge because the technology that we are using in the commercial has limitations, and until you can understand, one key thing is, for regulations to change, you need to provide them data. You can't expect FAA to come and implement new regulations every time a new technology comes into the airspace. So I'm just giving an example of FAA. When it comes to new technologies, you can't change the policy just because it's a new technology. New technologies have to show their capability. So when I've been working with small drones in 2014, the biggest challenge was to make people understand that this is a technology, because small drones at that time were toys. So when I used to go and talk to like my leadership, I used to talk to police departments, fire departments, tell them, hey, this is a small drone and this is going to solve your problem in the future. They would be like, yeah, come back when this is a little more sophisticated or this is good enough. But the thing is, at that point, if they had worked, we would have been able to solve the challenges pretty soon, but they didn't believe in the technology. So, every part of the way, there's even that we think about big challenges, but the thing is, the biggest challenge is public acceptance.
Oh, did we lose Darshan?
I think we did.
Technology.
Oh, there he is.
The right information. And that is what we are trying to solve here. So challenges I feel is like it's a public, it's a personal opinion. Everyone will identify some new challenge, which I might think is not a challenge, but that's because of the limited knowledge and the limited, exposure to the knowledge the person has. So over the years, small drones, then UTM came into effect. Many of the companies that focused on small UAS went into Counter-UAS and said, okay, now we know how we have built the technology. Now we'll show you how to stop our technology. And then you complicate the stuff, because now when the drones were just being, technology like drones were just being understood, you're selling them Counter-UAS stuff. And you're telling them, we can stop this from flying. So that's the thing. It's complicating and piling up upon problems. So over time, that's the thing. I don't really rely everything I read on. I believe it's better to be a part of those programs, be in the front and understand it from both sides. So when I worked for the state, I understood what the problems for state was. When I worked with FAA, I understood their problems. So I got a better understanding of why this delay is there and why everything is moving at a very, a slower pace in US compared to other countries. Just today, I heard one of the faculty saying in ESA, that is in Europe, equivalent of FAA, they are much advanced than us. I don't believe they're much advanced than us. I just believe that they are more easier, or their government is easier to work with. But eventually, everyone wants to work in US. They want to bring business to US. So we are going to be the main focus. So that's why we take a little bit more time. Our airspace is more busier. Our pockets are much larger. We have much more money to give. So it's going to take more time for us to believe in these technologies. So that's what I've seen in this years coming, in the last few years especially. And that's why I moved from small drones to eVTOLs, only because I felt like the small drone industry is too crowded now, and everybody is an expert. And it's I feel it's programs, students coming out of university programs that are focused on unmanned systems are going to take it to the next level. It's not the people who are in the industry, because most of the people you see in the industry are either one, coming from military background, two, they just got their part 107 and become a drone pilot, and they feel they know everything. So we want more people who go through the educational programs, who understand what these technologies are, and then see this moving a little more faster than usual.
So I think that's a good segue into my next question, which is, it's connected to your personal transition from smalls into optionally piloted aircraft, OPA. What are some of the more interesting traits or characteristics or just facets of optionally piloted aircraft that you've kind of come to see in the last, maybe 18 months or 2 years?
So, from that small drones to optionally piloted, or we call electric vertical, whatever aircraft you want to call it. One of the the elements that I've seen, which is interesting, is how we are bringing other emerging technologies into the discussion. That is, we are talking about autonomy, we are talking about security, cyber security, we are talking about integrating this into an airspace. We are talking about bringing in digital engineering. We are talking about this thing, what you call blockchain security. It's like one technology unifying a lot of other solutions, a lot of other technologies. So small drones, I feel, still is got a lot of potential, only because these aircrafts that we are talking about are going to have people on board. They're going to have cargo on board. So it should go through more stringent rules, more safety cases, while a small drones can be that testing technology, where if you want to test autonomy, you can test it on small drones and then eventually scale it to other aircraft. So this is where I made that transition, is because I know that it will be easier to integrate these aircrafts into the airspace only because there's a person on board these aircrafts. So when there is an operator on board, it operates more like manned aircraft, and like a more manned aircraft rule. So we'll be able to see a new technology transitioning into a a traditional airspace. So that is one thing, is how does new technologies, new entrants enter into a traditional airspace. So that will be very interesting, because even though these are not unmanned and autonomous at this point, they are still closer, very close to it. And if they can be integrated, then we start bringing in all the other components like autonomy and all these things and test it on small drones, and then able to integrate this within the airspace. So today's like discussions in Embry-Riddle, we are trying to see detect and avoid technologies. We are trying to understand the connectivity issue, because the airspace is no more going to be the airspace that we usually, what we know about. There's that whole discussion that below 400 feet, small unmanned systems. From 400 feet to 1,000 feet is going to be eVTOLs, drone delivery. And then above 1,000 feet is your traditional airspace. So you're going to see that layers. So those who are, who know about airspace and who are in that area, they will see that, that layer cake that we used to, draw before for airspaces is going to change the whole way we see things, because these technologies, there's going to be technologies at different airspace levels. And it's going to be a slow transition where you'll see more 400 feet initially, but then you will see a delay in 400 feet, but then from 400 to 1,000, you'll see new aircrafts coming into that picture. So what used to be our airspace is no longer going to be the way it is. So that's the whole amazing part about both these technologies. But with eVTOLs, we are like going to be experiencing, like when we used to fly drones, those who fly drones, we always imagined that time, what if we were sitting in that drone? So that's what is happening. The whole Jetsons, as they say, Elroy, when Elroy used to travel from home to school and school back home, that is now possible. I'm still waiting to see how an aircraft becomes a briefcase eventually. That will be something interesting to see, but we are getting there slowly.
So I have two questions from one of my students he's a rotary wing pilot, EHIS. His first is, how soon do you see advanced air mobility commence commercial operations, and which cities or city are most likely to see those operations first?
Great question. And, if each person you ask this question in this industry will give you different perspective. One key thing I can say is that the AFWERX Agility Prime program is looking to operationalize eVTOL by 2023 for a use case. Now, when you talk about advanced air mobility overall, you have to think about, are you talking about the final, result, or you're talking about a step-by-step approach? So first is identifying the use cases. So when it comes to states, we know that Ohio, Texas, California, even Florida is active in this space. We know that in Florida there is that whole corridor with Lilium. Same way California has a lot of efforts going on. Texas, I'm a deputy working with Colonel Riddler there, Martin Salinas, on operationalizing eVTOLs, working with universities there. So every state is really there. But I would say the key states are Ohio, right now, Texas, California, Florida. North Dakota has started discussions on what they can do. North Carolina has discussions. So when it comes to the final, product, it's going to take a couple of more years, maybe 2030, when we see a routine operation. But use cases we may see as soon as 2025. There are companies like Joby and Lyft and many other like Beta and all. They have already got buyers for these aircrafts. There are airlines giving billion-dollar contracts to get to buy these aircraft. So we are seeing in the next few years maybe some of these aircrafts in specific places doing specific use cases, and then from there it'll scale. So it's like drone delivery. If you see, has drone delivery expanded in every state? Not really, but North Carolina, California, there are drone delivery. Even in Florida, there's been drone delivery initiatives with many of these companies. So we're going to see initiatives and we're going to see use cases. And then the whole advanced air mobility is more, I would say, when autonomy kicks in. So when does autonomy kick in? Maybe 2030, maybe longer, because autonomy is still, to reach the level of autonomy from, we are right now, what? In drones, we are level 3, level 4.
And it's scalable, right? Yeah. I mean, we're working towards the upper levels.
Exactly. I mean, so when we reach that levels is where you can say advanced air mobility is a reality, or urban air mobility is a reality.
I would even go so far as to, if we were to stick a pin in where can you find the cities that you'll probably first see this adopted? Places that are already investing in vertiports.
Exactly.
The municipalities, the states that are really getting their own skin in the game, that they're matching funds or they're presenting funds, first up. They recognize the importance of this. As far as nations, obviously, you've got the US in there, but there's also folks like Dubai who are not only creating the infrastructure, but they're also incentivizing it through contests. So it's interesting to kind of see how all that'll kind of
and comes back to the point that like AFWERX, there's a team specifically focused on strategic capital, where we are trying to see where which states has incentives for these companies to set up operations, because they have the aircrafts are ready to fly for short distance or specific use cases, but they can't just take the aircraft to every city and do only flight demonstrations. There's a point where demonstrations end and revenue has to be generated. So this is where states are working, economic development organizations are working, and there is money coming from federal, state, investors are, commercial investors are coming in, because when you look at building this infrastructure, there is around that infrastructure also business booms. So, there's that opportunity. So if you build a vertiport, the companies, the space around the vertiport, the value increases. So, should a commercial entity come and invest in that infrastructure? Absolutely, because, say if you have a parking space, you're going to park vehicles there. So your, parking permits would increase, your parking taxes and all those things will increase. So state is looking into it. And this is where states that have understood the benefit of these technologies would be the early adopters. But I would say at this point, I would say about 30 to 40% of the states are getting there, but no one is going. You can't just point out one state and say that, yep, you're going to be the first one to do it, because if you look at drone delivery, it took by surprise. Like Amazon was shouting for years about drone delivery. And what happened? Companies like UPS, Flightrex, these guys we never knew about them till drone delivery came upon. But Amazon for years, before drone delivery was even a word, they were already talking drone delivery. So that's why I say it's like, not just because someone makes sound doesn't mean they have the answer to the problem.
So I have one more question for Mihis, and then I'm gonna open it up to the folks that are present. His second question does relate to AAM again. He asks, what are the top 3 challenges facing the deployment of commercial AAM?
One is, forget the regulatory. Everyone says regulatory. You have technology challenge, the batteries, and when you talk about electric propulsion, it's still not proved enough. We have still work to do there. But the overall thing is, how do we ensure there's a return of investment when it comes to these technologies? Like, you build these technologies, if you don't find the end user, and the end user, there's no investment coming from there, this technology is not going to be viable long enough. So when it comes to eVTOLs, if you identify use cases that are going to really solve a problem or going to help save time, money, then there is the deployment, I would say, is more successful. Just because you show these aircrafts and say that the future where rich people can travel by these aircraft, that's not going to be easy to win in every state and every place. So that's where use case is important. Technology still has to be tested enough to show its capability, and the third part is the whole acceptance part. Again, I mentioned public acceptance, because unless we have people who actually sit in these aircrafts and accept this technology, we're not going to be able to move. And there's already folks who have fear of flying. So are they going to be sitting in these aircrafts? I don't think so. And then those who are already like driving, are you going to convince them to stop driving and use these aircrafts? Maybe not. Not everyone would want to sell off their cars and just use eVTOLs in the future. So is it going to solve traffic? I don't believe it's going to solve traffic, because when the roads are empty, more cars will come. People will buy more cars everywhere. So that use case is where the problem is, and then public acceptance is the biggest challenge. I would say few people see the benefit of it, but there's a lot of education still needed, and states need to work hard on that.
Okay. Well, class, does anyone of you have any questions for Darshan? It looks like Jose, if you want to lead in.
Absolutely. I have a question. When we were doing the slides on the transition capability development, the baseline, what's the valley of death? What does that mean?
So so the valley of death is when for companies that have worked with DoD, and when they have many, you see some of the news that after like 6 years, the program died because one is there's no more, because, so as you working with these companies, you start or with this technology, you realize that one, they can get outdated. Second, what we believe that the technology can do, in years later, we find out the technology cannot be done. And then many times people who are leading these programs leave, move to some other program, and you're left without the person who had the vision to get this program in. So value of death has many other things also in acquisition. Like, okay, we see this technology is amazing. How do we get it to the end user within DoD? How do they buy these technologies? How do they, train the people? Because it's not like I can just go and buy 100 eVTOLs and just keep it in the hangar. It has to fly. It has to be used. It has to have people maintenance plan. It has to have a training program. So a lot of times, all these things don't come together, and after like millions of dollars, billions of dollars put towards the program, suddenly the program dies and it ends because of some failure, some crash, some issue. And so that value of death is because it takes so much time that eventually the program dies. So that's why these prime programs are trying to overcome that with a 3-year plan. So 3-year where we see the technology, test the technology, and operationalize the technology. So that's how we are overcoming. So that big valley is going to be more a straight line sort of approach.
Thank you.
And also to think about it, the program passes through different hands.
Exactly.
And so in that process also, one program may see the benefit, the other program is like, I don't see what's the benefit in this. So that is also the transition part, is where it goes from program to a program of record, and that kills the program eventually.
And after this, in our discussion area, I'll make sure to post, like I did last session, a series of links that connect to some of the concepts we talked about. I have a good one for innovation in the Valley of Death. It's a common concept that occurs in tech transfer. Typically in DoD type settings, you'll see adaptation of that technology, because it's usually just so costly that really you're hard pressed seeing private industry fund things of that nature. So they'll be put down for defense spending, and if it has potential utility, it's one of those things that can go to TTO, tech transfer office, and then out into the commercial or civil world. So this is just one of those risks that you incur though in that process.
Gotcha.
Looks like Robert has his hand raised. If you want to go next, Robert.
I was wondering if you could give a little more insight to the funding aspect of adopting new technologies. So it sounds like part of what your company does is talent scouting, and you find other companies that say, we have this product, we have this idea, we want to integrate it into the airspace or into like an aspect of DoD. As far as funding, does the DoD or does the government say, we have this need, and then companies say, oh, we'll try and build something, and they use their own startup to make a prototype, and then they get funding? Or does the government pass out like initial funds to companies willing to take on the opportunity to then make their prototype? How does that kind of work?
Sure. So we do have traditional, look at one side is we do have traditional contractors. We have General Atomics and stuff. They're the billion dollar programs that already DoD and the Air Force and Navy and Army and all work with. And here, what we are trying to do is bring innovation from startup companies, from companies that don't even have a office space. They are working from a garage, but they have amazing ideas. Now, we do have two ways to work with them. One is open topics, and the other one is focus topics. Focus topics is where we take problems from the DoD and put it out for companies to reach out to us and say, hey, I think I can solve this problem. And here's my proposal. So, it's like they submit the phase one is only, it's about 50K, but that phase 1 is basically a feasibility study. So, it's like out of 100%, out of 100 people who submit these proposals, and over 90% of them get the phase 1. So they get the initial 50K to show their feasibilities, basically their capability and stuff. So when they go to phase 2 is where they have to find an end user. Now, end user could be anyone within the DoD, but if they are, if they want to use the Air Force funding, that is the Air Force money, then they have to find an Air Force end user. Now, the Air Force end user may have that, see this as a problem, that is they are trying to identify a solution, or they may have never even identified this as a challenge, and the industry has come forward and said that this is going to be a problem. So for example, cybersecurity with eVTOLs. So as we were working with eVTOLs, they came up, some experts came and said, you're going to have problems with integrating these aircrafts or working with these aircrafts because they're all automated, and this is going to be having cybersecurity issues. So they're coming with solutions to solve those problems, and we are working with them. So pool of funding comes from ideas, where we are helping the companies through ideas, but also when you have a technology and you feel like this is going to help solve a DoD problem, we are giving them money as well. So we just don't give money and say, okay, come with the problem, but we do have open topics and focus topics. Where focus topics, like I said, is where we already have identified the problem, and we are trying to ask the industry to solve it. And open topics is where industry comes and tells us that this is going to be a problem in the future, and here is the solution for it. So we so this is where 2 ways where companies can work with us, and there is other ways also, that is through CRADAs and partnership agreements and stuff, where we partner with universities. So like my visit here to Embry-Riddle was to see how AFWERX and Embry-Riddle can work on initiatives under STTR. So STTR is where, as I mentioned, universities and research institutions work with small companies to provide the solution to Air Force or anyone in DoD. So NASA has CIBA, the Navy, Army, all of them have money through the Small Business Initiative.
So yeah, just a couple points of clarification, and I see a lot of this got covered over in the chat. AFWERX is a DoD organization under the Air Force. It's, if you recall from our last SME session with Ryan Langlois from, he's with the Munitions Directorate, they work together quite often. And he would be one of those phase 2 recipients where if you've received funding under an SBIR or an STTR, which, by the way, I'll send out details on what those are. If you've received funding under one of those, it's usually divided up into multiple phases, each one with a success gate. If you've completed phase 1 with, say Darshan's group, and he said, okay, well, what's next? We need more money, we need to add further complexity, and we need to find a mission. So we need a customer inside the Air Force or DoD. And that's where that other directorate might come in to say, well, hey, we love this. We love this idea. We need it. We'll fund it. So they take on that next piece. Would you say that's a correct kind of encapsulation, Darshan, of how SBIR?
Absolutely. So that's why I said, there's a lot of information that I can get in depth, which will, 1 hour won't be enough. But yeah, so we are DoD. I am a government civilian. We have active military. If you in simple words, what is AFWERX? AFWERX is a matchmaker. We connect the technology to the end user within Air Force, but through the Air Force to all the other DoD agencies as well as federal agencies. So we are matchmakers. We are not the end users. We manage the money. We make sure that the small business and startups get the money. Universities and research organizations get the money to solve the biggest problems, either which we have identified or which we have not identified yet. So that's the pool of funding. And just like us, there are different organizations having different pools of funding. Like I said, NASA has got their SBIR and STTR program. Army's got their own money, Navy's got their own. So everybody's got their own pool of funding at different, you can say that Air Force has more, a little bit more money than compared to someone else and someone else like that.
Outstanding. Are there any other questions from the class for Darshan? Alfreda.
Okay, can you hear me?
Yeah.
Sorry about that. You mentioned earlier on something about space and the garbage up in space. Would you expound on that some more? Just call a little bit of it. Just kind of interesting.
Sure. Again, I'm not an expert in that side, but I can give you a little bit of detail. Is that under SpaceWorks there is there's another prime that is called the orbital prime, where we have put out the challenge to the small businesses and universities that help us solve the problem in space with debris. There's a lot of debris that has to be cleaned. How do we solve it? And so we opened a phase 1 and direct to phase 2 window where companies submit a proposal. I think it's still going on. So companies can come up with the solution saying that we're going to build something for you that will go in space. And today we saw one of the technology in Embry-Riddle itself, where they got a claw that will be deployed in space, and it will pull the debris and bring it back to Earth and stuff like that. So it's like, how do we clean up the space? Because right now that's the biggest issue. So that's just a little bit of information. But again, it's going to be small companies, small startup companies and universities coming with the solution or partnering together, and they'll get the same pool of money, same pool of funding to solve that problem. And if you go to the AFWERX social media page, like if you go to LinkedIn or the Facebook page, and you search Orbital Prime, or if you just make a search on Google saying that Orbital Prime AFWERX, you will get more information about it. And if you're interested, possibly I can connect Brent to someone in the SpaceWorks to give one of these talks in the future.
Outstanding.
Right.
Thank you.
Well, class, I want to thank each of you for joining us, as well as a big thank you to Darshan. Remember, to receive credit for your participation this week, you need to develop that brief overview for assignment 6.3 that addresses just real briefly how our guest organization uses unmanned system technology, how lessons learned and observations made by our guests can help make new economic enterprises more viable. And then 3, any new information you're previously not familiar with, including how your overall understanding of the topic has improved. So I think that should be super easy to do, because Darshan provided extremely insightful material regarding how the Air Force is supporting the development and advancement of this technology for commercial use. So I think it's going to be really exciting to see what you guys all come up with. Hopefully I should have most of your module 5 stuff wrapped in the next couple days. Like I said, I'm starting to feel a little better, so hopefully I can get that done. But if anybody needs anything, don't hesitate to reach out. And Darshan, if you don't mind, I'll share your LinkedIn with everybody, if that's all right. Cool. Well, great. Well, everybody have an excellent night. In the case of Rob, excellent morning. It's 4 a.m. over there, probably working towards 5 now. So thanks again, and I look forward to seeing you all in 3 weeks. And Darshan, thank you again for coming.
Thank you, Darshan.
Thank you.
Everybody take care.
Bye-bye.